All right, so welcome to Module 3. Just a brief overview of what we're going to be covering in this module. Going to be talking a little bit more about reliability and validity. Also, there's going to be a delta index equation that's posted up to D2L that hopefully you'll be able to answer in the discussion question, or discussion section rather. Pretty straightforward, but again, some people get a little bit nervous when it comes to statistics. So this is kind of just meant to be more of a gear for me to figure out where you're at with it. This isn't necessarily graded on being right or wrong. Again, I just wanted you to give it a try. So we're also going to be covering a little bit more about specifying problems and goals. And short assignments number 1 and 2 are going to be posted under the materials for this week, or for this module. All right, so let me just start by pointing out what the delta index equation is going to look like. You can do this by yourself, or you can do it with a partner if you'd like. All right, so under the content for this module, you'll find this document, calculating change index exercise. So this is just essentially like a step-by-step process of trying to figure out the delta index. So here we've got a series of baseline data and intervention data. So you can do a simple sum here, which would just be adding these up, finding out what the mean is. So you would take the sum and divide it by 10. And you can see the directions over here on the left-hand column. And so on. You would follow these steps of subtracting the mean score for the baseline scores only, squaring these results, taking the sum of squares, taking the square root of that over the degrees of freedom here, which would be 9. So I know that this might seem really scary to some people and might be raising their anxieties, but again, rest assured you're not going to be getting graded on this. And what would probably be most helpful for you, as opposed to me just walking you through these formulas and maybe getting a little bit confused by it, I'm also going to post an example here. So from this example, you can see that I've already completed one for you. It's just going to have slightly different numbers. So here you can see how I walk through, add up these numbers to get the sums, divide the sums by the number of observations to get the mean, subtracting the mean from the baseline scores, squaring that, and ultimately figuring out what the standard deviation is. So for number 10, it also says to interpret the effect size from the z-score table. So if you'd like, you can try to give that an attempt. I'm not expecting you to necessarily do this. So you don't necessarily need to do this on your own, but I'm going to post up the z-score table, and if you want to try to follow the directions to figure out what the z-score is, to help you to figure out what the delta index is, that's fine. But mostly I just kind of want to see what your ability is to get through the first 9 steps. So again, try to have that posted to the discussion section before the beginning of the next module. All right, so back to reliability. And this is a really important concept in measurement. Using reliable measures is essentially giving us a measure that's consistent and that's going to give us the same results every time that we're using it. So again, another way of looking at this is reliability is an indicator of the extent to which a measure contains random measurement error. In natural sciences, again, I could look at my head circumference and I could take my head circumference 100 times with a tape measure and we could get the same result every time. But within the social sciences, there's a little bit more of random measurement error built into some of the tools that we're using. So random measurement error is, again, it could be administrative error, it could be error that's built into the test, whether the test may not be developed for the person that we're using it for, or it might not be for the purposes that we're using it for. So an example might be using a rubber band versus a tape measure to take the circumference of your book. So if you use a tape measure to take the circumference of your book, it would give us a reliable measure, and it would give us about the same measurement every single time. But if we used a rubber band, it might get a little bit more stretchy and it would be less reliable every time you used it because the rubber band would get stretchier. So that would be an example of measurement error. An example here is if clients complete a measure of stress, how could clients' current mood impact how they complete the measure? So let's say that we're meeting with somebody who is really stressed out with work, not getting along with coworkers, not getting along with their boss, and you were seeing them to help them deal with some of the stresses from their occupation. So if you were getting this measurement every single week that you met with them that was giving you reliable outcomes, reliable measurements. And then one day, right before you meet with them, they get into a car crash. And so their stress is through the roof. This could cause random measurement error because as a practitioner, you might be looking at their stress levels every single week, and all of a sudden they had this car crash where their stress is just spiked. And that doesn't necessarily mean that you're a poor practitioner or that your intervention isn't working per se. But the reason that their stress is spiked is because of the car crash and not necessarily because of anything that you're doing or anything associated with the intervention. So again, that would just be measurement error that would give you a little bit misleading results or unreliable results. In talking about reliability, what is unreliability? So this means inconsistency in a measurement due to random measurement error. And random error refers to the possibility that responses to a measurement could be affected by chance or a haphazard occurrence, such as a car accident prior to somebody filling out the measure. But it could also be something like a polar vortex hit and a person's really stressed out about that, or perhaps it's the flip side where it's 100 degrees and really humid and a person's really irritable, so they're more stressed out. This kind of begs the question of how would we know if something's reliable, right? You might be thinking that, well, we want to be measuring changes in this person's stress level over time, right? So it should change, hopefully. And if it's changing, that doesn't necessarily mean that the measure is unreliable. So how would you make sure that a test is reliable? So reliability is determined by repeatedly and independently measuring the same people under the same circumstances. By independently measuring means that the observation of the first time that you're administrating the test isn't going to influence the second administration. So you might want to make sure that there's enough time between the two administrations. So maybe giving somebody a stress test today, and then a follow-up on 1 week from today, and then another one 3 weeks from today. These would all be independent of each other because they're happening at different times and different intervals. So an example might be intelligence testing. You have to wait 1.5 years between administrations of an intelligence test to have them independent. Because if I gave you an intelligence test today and gave it to you tomorrow, chances are that your test the second time would make you look like a genius. And it doesn't mean that you got super intelligent overnight, but it means that by taking the test 2 days in a row, you probably know what to expect. You kind of know what the questions are going to be. So maybe you went home and studied. Maybe what does that word mean that I heard in the test that I'm unfamiliar with? So your test scores would boost up tremendously if I gave it to you 1 day in a row, or maybe 3 days in a row. But by independently taking it, you would make sure that there was enough time in between the measurements so that they weren't influencing each other. So under the same circumstances would mean that we would want to be using the same test with the same facilitator. You'd probably want to have it in the same type of environment. So if you're using it in a university counseling center, you'd want the second administration to be in a university counseling center by the same administrator. Because let's say that if you gave somebody a stress test in your office 1 week, and then you gave it to them at their workplace the next week, and you gave it to them at a family gathering the week after, these would definitely be under different circumstances and would influence the reliability assessment of your measure. So when we're coming up with the test, there's a few different measures of reliability. And one of the most basic ones is test-retest reliability, and that's kind of similar to what we were just talking about in the previous slide. So test-retest reliability is a test of the stability or consistency of a measure by calculating the correlation between the first and second administration of the measure. So this is hugely important in single system designs because we're going to be repeatedly measuring somebody with the same tool over time. So we need to make sure something's got test-retest reliability. So if I gave somebody who was struggling with substance abuse dependence or substance abuse or substance dependence, and I gave them a measurement today, I would want the results to be highly correlated to their measure 1 week from now. And again, hopefully it would be correlated to 3 weeks from now, or strongly correlated. Because if I gave it to them on 1 day and it was wildly fluctuating from the second assessment, your measure is definitely not going to be reliable, and it might not even be valid. It might be measuring something that we're not intending it to. So when researchers are developing tests, they want to make sure that somebody's getting multiple administrations of the test and having similar results every time they're taking it. So just a refresher from some of your previous courses, what is correlation again? Correlation again is how strongly related the first measurement is to the second measurement. So if two measurements are perfectly correlated, let's say my height measurement today and my height measurement tomorrow at the same exact time, those should be pretty close to a +1 correlation. So +1 is as close of a correlation as you can possibly get. And -1 is complete opposite, so as far apart from a perfect correlation as possible. And depending on how close you are to 1 or -1, it will tell you about the strength of the relationship. So here's an example of a perfectly negative correlation. If we took maybe this white circle and this blue circle, and these are two different test administrations, there's no overlap between the two of them. So there's no correlation whatsoever between these two measurements. But let's say these were the same measurement or the same two test administrations, but there's about 50% overlap. Then we would say that there's a moderate correlation between the two of them, because there's definitely some overlap between the scores. Let's say that 50% of the items they endorse the first time overlap with their second administration. Then there's a moderate correlation between the two measurements. But when the rings are together, let's say the first time they took the test and they endorsed every single symptom of substance dependency, and the second time they took it, they endorsed every single item of substance dependency, then that would be a perfect 1, positive 1 correlation. So they're 100% overlap. And you don't necessarily need to remember this, but just for some general guidelines, above 0.90 is very strong correlation. 0.81 to 0.9 is good. 0.71 to 0.8 is acceptable. And for research standards, generally something that's less than that is considered poor. So if you've got two measurements that we're looking for their reliability and they're less than 0.7, probably that correlation could be just by chance alone. So there might be some overlap between substance abuse and depression, but there should be more strongly of a correlation or a relationship between two measures of substance abuse than a relationship between a measure of substance abuse and depression, which is probably going to have strong overlap, but not quite as strong as two measures of the same thing. So another measure of reliability is internal consistency. So this is the extent to which people respond consistently to items that are within the same measure. So if I'm going to be creating a measure of life satisfaction and somebody is saying that they're really happy in life with all items are saying that life's great, and I give the same test to somebody else and they're really struggling with life and they say that they don't endorse any of these life satisfaction items and they're endorsing them all negative, we would probably suspect that there was strong internal consistency because people are rating the items consistently, whether they're happy with life or not happy with life. But let's say that somebody was taking it and their first half of the responses, they're saying, yes, I'm really happy with life. And then halfway through the test, they start saying, I'm really unhappy with life, and endorsing all these items that are saying that they're feeling really depressed or unsatisfied with their work. We would start to question whether or not the test was measuring the same things all throughout it. So that might say that the test had poor internal consistency. Because if we're trying to measure the same construct with all of our items, the person should be responding to all the items in the same direction. And if they're not, and their responses are all over the place, it would probably tell us that our test isn't reliable within itself. So in order to measure this, just like the correlations between the two testing, a coefficient alpha is going to help us to look at the internal consistency within the measurement itself. So how strongly correlated the items within this measure are to each other. So an example here might be the Sexual Experiences Questionnaire, measures sexual harassment in a workplace. And it's reported to have alpha reliabilities ranging from 0.78 to 0.88. So by the standards of research for what's a strong alpha reliability, this would be something that you could administer to your client because this is something that has relatively strong internal consistency. So again, by looking at this, you would suspect that if somebody was endorsing a lot of sexual harassment at work in the beginning of that assessment, they're probably going to be endorsing a lot of sexual harassment later on in the same assessment.